Hey guys, today we're going to start with some math warm-up, so make sure you have some scrap paper and something to write with so you can get started. You'll also need your math journal. We're going to be doing page 199 and the lesson to go with that today. So here's our warm-up first. Make sure you have what you need. Pause the video so you can get what you need. Okay, good afternoon. We are looking at doing a warm-up of practicing our estimation skills. We have done this before. This involves several different skills like rounding up and down, finding the closest number, the closest whole number by tens. These are all things that we've learned before, but we want to do some quick practice. So I'm going to do these 6 problems with you, and then I have 3 problems that I want you to do on your own. So please, on your scrap paper, make sure that you're following along. So when I am estimating, I'm not trying to add the 2 numbers up and get an exact answer. I'm just trying to get close enough. So this is good for like if you're going shopping and you know that you want to figure out how much your shopping is going to cost, but you're not going to add up every 99 cents. You're just going to round up to $1 and count each item as costing $1 in your head if you're trying to shop on a budget. So here I have 2 numbers, 72 and 21. So if I'm adding these together, I'm going to get an exact answer of 93, but that's not what we're trying to do. We're not trying to get 93. What we're trying to do is look at each of these numbers, figure out what they're close to. So 72 in my head, I'm saying, okay, 72, that's close enough to 70, plus 21, that's close enough to 20. So if I'm adding these together in my mind, which is our goal to be able to add numbers in our brains, my answer is going to be 90. It's close enough that I don't need to know exactly that it's 93 for the purpose of this strategy. So now I'm going to look at number 2. 33 and 49. So in my mind, when I look at the number 33, I say, that's close enough to 30. And I look at the number 49, and that's really close to 50. So I'm just going to add 30 plus 50. Looking at the 3 plus the 5, that makes 8. And I keep my tens, so that makes it 80. Really quick in my mind. This is a quick way to add when you're out in the world, and you're just trying to figure out about how much something would be, or about how much of something you have. 64 and 29. Well, 64 is pretty close to 60. 129 is pretty close to 130. So I'm going to add these 2 numbers up, and I look at the tens place. 6 and 3 equals 9. I want to keep my 100. 190. And that's how fast we can do that in our brain. You'll do it even faster as you keep practicing. Now looking at these 2 numbers, 125 and 55. So 55 is pretty close to 60. 125 is pretty close to 130. Another way you can look at it though in your mind doing some mental math is you can combine these 2 5s to make 10. And then I know that 50 plus 10 is 60 plus 120. If I wanted to do it that way, I would get an answer of 180. If I do it this way, I get an answer of 190. Either answer is correct. It's just about trying to practice doing this math in your head. That's the thing with having a 5 in the ones place. It can go either way when we're doing estimating. We could round it up or we could round it down depending. Also, 5 should be pretty easy to combine. Most of you hopefully have your addition of 5 plus 5 equals 10 already memorized. Looking at number 5, we have the numbers 174 and the number 210. So I'm mostly just looking at the tens and ones, and I'm going to keep my 100. 74 is close enough to 70. Plus 210 already has a 0 there, so I don't need to round it. So I'm going to combine my 10 and my 70 first, and I get 80. Then I'm going to combine my 2 and my 1, and I get 3, and my answer is 380. That's my estimate. The answer is about 380. Next, I'm going to look at this last problem. So 396, 96 is pretty close to 100, so I'm going to make this 400. Plus 473, I'm going to keep that 470 because it's close enough. So in this case, it's actually easier for me to combine my hundreds first. 4 and 4 makes 8, 800. And then I have 0 tens and ones over here and 70 tens and ones. So my answer is going to be 870 when I combine those two together. So that's the way that you can use rounding to help you estimate. The goal, again, when we're doing these warm-ups is to be doing this kind of math in our head. Of course, we have to practice on paper as second graders until we develop the skill of being able to do addition and subtraction in your head. It's not something that comes easy to everyone. It requires a lot of practice. It's not something that ever came easy to me. When I'm in the store trying to add things up, I'm still kind of counting on my fingers sometimes. You will hopefully be better at it than I was when I was your age. So now I'm going to give you a couple problems to try. By the way, if anything goes too fast for you, just pause the video when I'm teaching and go ahead and do it, at your own pace. And again, this is just a warm-up. Do it on scrap paper. Here's the ones that you can do on your own. So I'm just going to pause the video here so you can see these three problems. Again, round up, round down, whatever you need to do. The goal is quickly mastering these mental math skills and adding these without adding exactly. So 51 and 33 are pretty close to 50 and 30, and then you add those two together to get your answer. Practice these on your scrap paper. When you're done, we'll be moving on to our math journal. Pause the video now so you can get these three problems done before you move on. If you haven't finished, pause the video and finish your work before we continue. So today, this past week, we've been learning about flat shapes. So here are some just reminders of the flat shapes we've learned about. We have learned about triangles, which are three-sided shapes that have 3 angles and 3 vertices. And there's 3 examples of triangles here. Each of these triangles has a name. A triangle that has equal sides all the way around is called an equilateral triangle. And you'll learn more about that in 3rd grade. A triangle that has a right angle in one of the corners, a 90-degree angle in one corner, or a square angle, whatever they're going to call it, is called a right triangle. And a triangle that looks like this, it's all the angles are different, is called an isosceles triangle. I don't know if I'm spelling that right, but isosceles triangle. Basically, most triangles are isosceles triangles. There's other things that we would identify as triangles. Triangles, again, these are all flat shapes. So none of these, like a pyramid, is not a triangle. It is a shape that is made of many shapes, many flat shapes, including triangles and squares. So then we also have our quadrilaterals that we've been learning about. Quadrilaterals, again, are shapes that have 4 sides, 4 angles, and 4 vertices. Sometimes they can be right angles, like this square and this rectangle, and sometimes they are not right angles, like these other shapes. If you look at all these shapes, they are all 4-sided shapes. We can count them: 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Some of them have names as well, like this one right here is called a parallelogram. I ran out of space. parallelogram, which basically means that it has four sides that are parallel to the opposite side. That means that these sides were never connecting. They'll never connect together in a thing. And then this one down here, this is called a rhombus. Some people like to call it a diamond, but it's not a diamond. It's a rhombus. And then finally, the thing that we have not learned about is about polygons. So polygons are shapes that have many sides. The word poly means many, and the word gon means side. The part of the word means sides. So polygon is a shape with many sides. Shapes that fit into that category are hexagons, trapezoids, trapezoids, no, sorry, not trapezoids, pentagons. Trapezoids actually go up here. So a trapezoid would belong up here in this category, in a four-sided shape. But we have other kinds of polygons. This shape right here, it looks like a bunch of random lines. It doesn't have a name, so we just call it a polygon. Not all polygons have names. Like these two here don't have a name. This one here doesn't have a name. Well, it's kind of a stretched out hexagon because it does have 6 sides. But we would just call it, any shape that has more than 4 sides is going to be called a polygon. We're not going to get into polygons that much in our coming units, but I wanted to quickly introduce them so you can at least know and have heard that word before you go to 3rd grade. So our focus today is on this category, quadrilaterals. And we're going to look at page 199, and we are going to look at each shape and we're going to test if it's a quadrilateral. In order to do that, we have to see, does it have 4 sides, 4 angles, and 4 vertices? So that's our test. And we're not worried about, is it a square or a rectangle? We're worried about, is it a quadrilateral? So that's what we're going to be looking at. Turn to page 199 in your math journal, and let's look at each shape and decide whether it's a quadrilateral or not. Okay, today we are looking at page 199 of your math journal, and we are looking at all of these shapes and deciding which ones are quadrilaterals and which ones are not. Here's an example of a trapezoid, by the way, since I missaid that earlier. But looking at these shapes, we have to decide these shapes are quadrilaterals and these shapes are not quadrilaterals. So we're trying to figure out why each shape up here is considered a quadrilateral and why these shapes would not be considered a quadrilateral. So let's start by looking at shape A. Give me a moment while this opens up. So starting by looking at shape A. If I look at shape A and I see shape A right here, I can prove that this is a quadrilateral because it has 1, 2, 3, 4 sides. It also has 4 angles and 4 vertices. Okay. Next, looking at shape B, if we count the sides, even though it kind of doesn't really look the same as something like shape A or shape F, it's also a quadrilateral because, again, it has all of those 4 sides, like right here, 1, 2, 3, 4, and it also has 4 angles, 1, 2, 3, 4. Even though this angle is going the opposite direction, it still counts. And within those, outside of those angles are the 4 vertices. So shape B is also an example of a quadrilateral. Looking at, say, shape C, this is a square, turns on its point. It is very clearly a quadrilateral with 1, 2, 3, 4 sides and 4 angles. So we can prove that this is a quadrilateral if we check for those sides and angles. Looking at shape D, same thing. 1, 2, 3, 4 angles, and 1, 2, 3, 4 sides makes it a quadrilateral. And you can see also that shape E and shape F are both quadrilaterals. Shape A and E are both called parallelograms. Even though they look slightly different, They are both examples of parallelograms, just one is bigger than the other. Shape F, also a rectangle, and we know that all rectangles are quadrilaterals. So now looking at these shapes, why aren't these shapes quadrilaterals? So let's start with shape G. Shape G only has two sides. The other two edges here are curved. And if it has a curved side, then that is not an example of a quadrilateral. Quadrilaterals all have to have straight sides. All quadrilaterals, triangles, and polygons have to have straight sides. If the sides are not straight, it is not considered a quadrilateral. Then we have shape H. Well, shape H has 1, 2, 3 sides. So automatically we know it's not a quadrilateral because quadrilaterals all have to have 4. Now let's look at shape I. 1, 2, 3, 4, 5 sides. Well, that means it is not a quadrilateral. This is a polygon. So this shape is not a quadrilateral, just like H is not a quadrilateral. Shape J, let's count the sides. We start with the sides, that's the easiest one. 1, 2, 3, 4, 5, 6 sides. Well, that's definitely not a quadrilateral. It's another polygon. Shape K isn't even actually a shape. This is just some line segments. These, because it's not, when we look at the bottom right here, it's not closed up, then it's not actually a shape. This is just a bunch of lines. We cannot call just anything a shape. A bunch of jagged lines, if it's not closed all the way, is not a shape. Shape L is closed all the way, but there's definitely more than 4 sides. 1, 2, 3, 4, 5, 6, 7, 8 sides. This is actually an octagon. It's an 8-sided shape. It's a kind of polygon. It is not a quadrilateral. It is a polygon, but we're not looking for polygons. Now, what we're looking at these shapes, and I just want you to say out loud to a friend or a family member who's living in your house with you, and tell your family member, what does a quadrilateral have in common? So all of these shapes at the top, what do they all have? And so then remind yourself, what are those attributes of a quadrilateral? And what is wrong with some of these shapes? Review for yourself, why are these not quadrilaterals? That is going to be it for looking at this. Go ahead and pause the video so you can tell someone what you learned about quadrilaterals today. Now we're going to look at the home links that is available for you to do. If you look here, it's home link 8-4 in your home links book. It's page 219. And for the home links, it says draw a quadrilateral that has 4 right angles. Use the dots to help you. So you're going to, on your dot paper, little square, little space right here, you're going to draw any shape you want, but it has to have 4 right angles. So remember, a right angle means that you could put a corner of a piece of paper on it, and it would match. Both edges would match if it has a right angle. So if a quadrilateral has to have 4 right angles, that kind of limits your choices. There's only 2 shapes that you could make that are going to have 4 right angles. So a right angle has to look like the letter L. In order for you to make a shape with a right angle, it has to be like an L. So you cannot have any diagonal lines in this shape. This one says draw a triangle that has 1 right angle. So use the dots to help you. That means that in this shape, you need to have 1 letter L. So one of the corners, one of the vertices, needs to look like a letter L. It needs to be a right triangle. The rest of the triangle can look any way that you want, but a triangle, again, is only going to have 3 sides. What is different about a quadrilateral and a triangle? So you're going to think about what we talked about at the beginning of the lesson where we reviewed our shapes and write down something that's different. And then what can we do to test if an angle is a right angle? And we've talked about this, holding up a corner of an envelope or a piece of paper that's been cut exactly. Those are ways we can test something is a right angle. And then finally, there's some practice math problems on the bottom. That's just something you need to do. This is independent work. I'm not going to go through it. It is one of the things that you could tear out of your book to turn in. If you have any questions, as always, feel free to connect with me during drop-in time or have your family send a message if you can meet a different time. And that's all for math today. Have a great